Hey everyone, today we're going to be working on Lesson 10, Compare Real Numbers. Our objective is to compare mathematical expressions. So first of all, let's take a look at two big categories of real numbers. First, we have rational numbers, which are numbers that can be expressed as a ratio a-b. And remember, where a and b are integers and b cannot be 0. So examples of rational numbers are integers like -2 and 5, repeating decimal like 3.76, and a mixed number like -12 and 7/8. Then we have irrational numbers. An irrational number is a number that cannot be expressed as the ratio a over b, and of course where a and b are integers and b is not equal to 0. So irrational numbers are a pretty small category. For example, square roots that are not perfect squares, like the square root of 2 is approximately 1.412 and so on. This is not a terminating or repeating decimal. It just keeps going on to infinity. So irrational numbers do not break down real easily. Numbers that are not rational are called irrational numbers. The square root of any number that is not a perfect square number is irrational. The set of rational numbers and the set of irrational numbers together make up the set of real numbers. Study the Venn diagram below. So this diagram looks pretty complex at first view, but let's break it down. First of all, this whole category, all the numbers in the box are real numbers. So as far as rational numbers are concerned, rational numbers are everything inside of this box on the left, the white box. So it's fractions, it's repeating decimals, it's terminating decimals, percentages, and negative fractions. Now if we go into the blue oval, all the numbers inside the blue oval, the yellow circle, and the green circle are integers. So positive and negative numbers, basically. Whole numbers are all of the positive numbers and include 0. And then finally, natural numbers are just the positive integers above 0. So really, if we look at it that way, basically working from the outside in, all are rational. Everything inside of the blue oval, including the two center circles, are integers. Everything inside the yellow and the green are whole numbers. And then everything inside the green would be a natural number. In contrast to that, irrational numbers are numbers like pi. That's approximated at 3.14. But actually, pi has a decimal that goes on forever, basically. Here's another non-terminating decimal. And here's an example of a square root of 3 that is not a perfect square. So let's take a look at some examples. For these three problems, we're being asked to name all sets of numbers to which each real number belongs. So we want to know what categories do these particular values fit into. So here we've got 0.2525, which is a repeating decimal. So we would say the decimal ends in a repeating pattern. It's a rational number because it is equivalent to 25 over 99. And remember, any repeating decimal can be put over the value 9 or 99 or 999, depending on the repeating pattern. Square root of 36. Since the square root of 36 equals 6, it is a natural number, a whole number, an integer, and a rational number. So we're not only looking at the value, the square root of 36, we're also looking at its square root, because that's just another way to represent the square root of 36. So 6 falls into all of these categories. And then finally, the negative square root of 7. The negative square root of 7 is approximately 2.64 and so on. The decimal does not terminate nor repeat, so therefore it's an irrational number. So I'd like you to try these three problems on your own and then come back and check your answers and see how you did. So for A, we've got the square root of 10. The first thing I ask is it a perfect square? And the square root of 10 is not a perfect square. So that tells me that it's an irrational number. If I look over at my real number diagram here, I know that a number that's not a perfect square is an irrational number. So I can say that it's irrational. For b, negative 2 2/5. I can just go right to my chart. And if I'm looking around, I know that a value that includes a fraction would fall into the rational numbers category. So it's a rational number. And then finally c, the square root of 100. Again, I ask, is it a perfect square? And I know that the square root of 100 equals 10. So the answer is yes. And then I look at my chart, and I can see that 10 is in the center of all of these categories. So it's a rational number, an integer, a whole number, and a natural number. So it's rational, it's an integer, whole number, and a natural number. Now let's talk about comparing and ordering real numbers. You can compare and order real numbers by writing them in the same notation. Write the numbers in decimal notation before comparing or ordering them. So in each of these cases, we're going to convert our values into decimals so we can make a really quality comparison. We're asked to fill in the circle with less than, greater than, or equal to make a true statement. So here we have the square root of 7 compared to 2 2/3. So if we take the square root of 7, we get approximately 2.6 and so on. And if we break down 2 2/3 into a decimal, we get 2.6 repeating. So when we compare 2.64575 and 2.6, we know that 2.64 is less than 2.6. So therefore, we would place our less than sign in the circle. For 5, we're comparing 15.7% to the square root of 0.02. If we convert 15.7% to a decimal, we get 0.157. Take the square root of 0.02, and we get approximately 0.141. So since 0.157 is greater than 0.141, 15.7% would be larger than the square root of 0.02. So we would put the greater than sign in the circle. Number 6, order the set square root of 30, 6, 5 4/5, and 5.36 from least to greatest. Verify your answer by graphing on a number line. So a number line will be really helpful when we're comparing here. First, we need to write each number as a decimal, then order the decimals. So the square root of 30 would be approximately 5.48. Obviously 6 is 6.0, 5 4/5 would be 5.80, and 5.36 repeating would be approximately 5.37. So from least to greatest, the order would be 5.36 repeating, the square root of 30, because the square root of 30 was 5.48, 5 4/5 because that is equal to 5.80, and finally 6 because 6 is just the largest value. So to wrap things up, no assignment today. We did our practice problems within the lesson, and we will pick up with part 2 tomorrow.